Alright, so this video is going to talk to you about how to verify trig identities. And so a trig identity is something like, say for example, you got 1 plus tangent squared of x equals secant squared of x. So the idea here is that you are going to prove or show when you're verifying the identity, you're going to prove or show that the left side equals the right side, or vice versa, that the right side equals the left side. So what you have to do, the rules to this whole game, and I kind of like it like a game or a puzzle, that I'm starting and I know where I'm starting and I know where I'm ending, but I don't know how I get there and I have to figure that out. And so you have to stay on one side. So this is not like solving an equation where you like add or subtract things to both sides to make them, to solve for the variable or anything like that. What you're doing is you're staying on one side, and so that's where you're doing all your work, and you're going to show that one side equals the other. And so that's kind of the idea. So first, make sure you stay on one side, and two, you'll be done once you've shown that the one side equals the other. So I am going to work on the left side. So we're going to show that 1 plus tangent squared equals secant squared. So watch this. Here we go. So what do? You're like, ah, shoot. Okay, 1 plus tangent squared. What do I even do with that? Well, maybe I will use a quotient identity, right? Right there. Sine over cosine. So I've got 1 plus sine squared of x over cosine squared of x. You're like, okay, how does that help? And you're like, well, now it's a fraction, and I know how to add fractions, so 1 over 1, I need a common denominator, so I'm going to multiply by cosine squared on top and bottom. So that's going to give me cosine squared of x over cosine squared of x plus sine squared of x over cosine squared of x. And now as we look at that, we can add the tops together, right? So we'd have cosine squared of x plus sine squared all over the numerator, cosine squared of x. And if you know your Pythagorean identity, which is sitting right here, sine squared plus cosine squared is 1. So now you have this whole thing kind of shown almost there. And you have 1 over cosine squared, which is secant squared of x, and now you've shown that the left side equals the right side, secant squared. And so we verified that 1 plus tangent squared, we've made it all the way. We've shown that the left side can indeed be written as the right hand side. And so now if somebody says, how do you know that's true? You're like, well, dude, check it out. I just showed you how it's true. And so there it is. So that's the idea about verifying a trig identity, is that you're working on one side and you're showing that it equals the left side or the right side. So take a look at, picked a couple examples just to do, and really the best thing for you is to practice. Just to practice, and memorize the identities so that you can just kind of work the puzzle out. Also invest in an eraser because you're going to screw up sometimes. So here you go, first one. Secant of x plus cosecant of x, all divided by 1 plus tangent of x equals cosecant of x. So when you're looking at this, to pick which side, you have to pick a side, that you're going to work on, and you have to stay there. And so then you look at this and you're like, well, the right hand side only has cosecant. It doesn't seem very helpful. The left hand side has a lot of stuff going on, and so that's usually the side I'm going to start with because I've got more to work with. And so one good strategy is you look and you say, okay, I'm trying to get it to be a cosecant. So I don't see any tangents on the right hand side. I don't see any secants on the right hand side. So one of the things that a lot of people will say to do, a good strategy to start with, is to turn everything into sines and cosines. So secant is 1 over cosine plus 1 over sine for cosecant. And this is no guarantee that this is going to work, but I have an idea that it might work because on the other side it's only 1 over sine. And so then I have 1 plus sine of x over cosine of x. So on top we have two fractions being added together. On bottom we have two fractions being added together. We need to add those fractions together first before we do anything of multiplying by the reciprocal. So I guess just requires work, right? So this needs to be multiplied by cosine of x and cosine of x. This needs sine of x and sine of x. And so on the top we would have sine of x plus cosine of x all over sine of x times cosine of x. And that's my denominator. So that's the top. Okay, let's look at the bottom. This 1 is going to be 1 over 1, and it's going to be cosine of x and cosine of x, and that's all we need. So on the bottom we would have cosine of x plus sine of x all over cosine of x. So now what do you do when you multiply by, or when you divide two fractions, you need to multiply by the reciprocal. And so I'm actually going to write it right next to our numerator. So we're going to multiply by the reciprocal of this guy. So it's going to be times cosine of x over, and then cosine of x plus sine of x. So we flip that guy, and that's what we're multiplying by. So don't look at that anymore. So now when we look at this, what can reduce? Well, sine x plus cosine x, this thing, is the same as this thing, and so those factors will reduce. And then cosine over cosine will also reduce, which leaves me with, and works a little messy here, but 1 over sine of x. Hopefully you followed. And what is 1 over sine of x? It is cosecant of x. And so we've shown that it equals cosecant of x on the other side. And so we're good. We verified it. So one thing to do is look and see, how does the left side relate to the right side? Sometimes it's a good idea to work on the side that has more going on with it. But the more you practice, the more you'll kind of build your own routine of how you kind of work through everything. Take a look at this example. Second one is secant of x plus tangent of x equals cosine of x over 1 minus sine of x. Here's the thing about this one, is as you look at it, either side really is something you could work with. You can work with either side. It's not going to hinder you. You can do a few different things with each side, and they will be able to be proved and verified. It just depends on what you want to do. Most people might try the left side, because I feel like people always get into a routine and they always start on the left side and show that the left side equals the right side. But I'm going to be a rule breaker here, a little rebel, and I'm going to start on the right hand side. And so I'm going to start on the right hand side, and I'm going to show that the right hand side equals the left hand side. I know, very daring, outside of my comfort zone here, but that's okay. So on the right hand side I have cosine of x over 1 minus sine of x. I look at this and I say 1 minus sine of x, if I multiply by the conjugate, 1 plus sine of x on top and bottom, then I'll have cosine of x times 1 plus sine of x. And what happens when you multiply by the conjugate? Well, you get difference of squares. So 1 times 1 is 1. The middle parts will cancel out and then be minus sine squared. If you know your Pythagorean identities, you know that 1 minus sine squared is cosine squared. So you'll have cosine of x times 1 plus sine of x all over cosine squared of x. And so hopefully you can see that the cosines will reduce, and that will leave us with, right, if we can reduce those cosines, that will leave us with 1 plus sine of x all over cosine of x. Now it doesn't look like the left side yet, but we do know that division is allowed. You can divide, so I'm going to divide this cosine into both terms on the numerator. And so 1 over cosine of x plus sine of x over cosine of x is the same as secant of x plus tangent of x. So there I have shown that the right-hand side equals the left-hand side, and that secant of x plus tangent of x is something you can get from that side. And so it's okay to start on either side. And so when you start on either side, you just need to make sure you stay on that side, and that then you show and simplify that side down so that it looks like the other side. And then you're good. So we've done that. Hopefully you practice well and you've been memorizing, and good luck to you, and feel free to like, subscribe, leave a nice comment, maybe this will be a revolutionary YouTube thing where people only leave nice comments, not negative comments, but hey, whatever. All right, have a great day. Goodbye.